Hey guys, welcome back again to our unit on bonding and molecular structure. We're going to hang out in C.3.4 for a while. We're going to have 7 days of material on this because it's really important and it's very complex. There's a lot that goes into this. So we're going to learn to write chemical formulas for ionic compounds and covalent compounds given their names and vice versa. So this is critical recall, okay? Atoms are neutral, which mean that they have the exact same number of protons and electrons. An element is defined by the number of protons in the nucleus of a single atom. An atom of an element can gain or lose electrons. Remember that. We have new information that we're looking at here. An ion is an atom or compound which has a positive or negative charge. This occurs when there is an uneven ratio of protons and electrons. A valence is the combining power of an element, measured by the number of electrons total in an atom, element, or compound. You need to know valence charges by looking at the periodic table to properly write and name. Intro to valences. Intro, again guys, is shorthand for introduction. Step 1. Learn to use your periodic table. Everything in column 1 has a +1 charge. Everything in column 2 has a +2 charge. Everything in column 13 to the left of the staircase has a +3 charge. This is also column 3A, okay? So column 3A, also known as column 13, left of the staircase, all right? The black line is the staircase. Ions to the left, when formed, are positive. Ions to the right, when formed, are negative. Okay, so the staircase is super important, guys. Know the staircase, all right? Ions in column 15, also known as column 5A, all right, or group 5A, ions in this column have a -3 charge. Ions in this column have a -2 charge. Ions in this column have a -1 charge. Now, I realize that this can be a little tricky, okay, right? Because you're thinking, well, we've got groups 1, 2, 3, 4, 5, 6, 7. How can a 7 have a -1 and a 6 have a -2? And how does this make sense? Well, here's what it is, folks. You've got 7 plus 1 is 8, okay? 6 plus 2 is 8, okay? So I want you to be thinking, about how these combine to fulfill the octet rule. Remember, these are the noble gases. Everybody wants to have 8 electrons, their valence shell. Everybody wants to be a noble gas because everybody wants to be a noble, a king or queen in their own right, okay? So that's basically what's happening again here. Metals are to the left of the staircase. All right, everything to the, know the staircase. Metals are to the left and they form positive ions. Okay, non-metals are to the right and they form negative ions. So metals are positive in general when they form ions. In general, non-metals are negative when they form ions, okay? All right, this is Valence Practice. So I'm going to go ahead and pause the video and we're going to work this out. Good job, guys. Okay, cations are positive. Cats have paws. Look at that cute cat with its little paws. He is positive. He's a positive cation. Look at his face. Okay, all positive ions are cations, consisting of only one element remaining the same. So what happens is a calcium becomes a calcium cation. So when you're naming it, you have to really keep the same name of the element, but then you're just adding cation to the end of it. Does that make sense? So calcium becomes calcium cation. Okay, so I'm not writing calcium's cation. Okay, if I had more, I would write calcium cations, right? Or magnesium cations. So we see the chemical symbol from the elemental the periodic table of elements, and then the name. So remember, it just ends in cation. If you have a cation, it's the same thing. It's just becoming a cation. Calcium cation, magnesium cation, and potassium, of course, yields a potassium cation. All right, I'm going to pause the video and we're going to work this out. How are we going to name these? All right, anions are negative little electron thieves. See, here we have the thief with the purse. We kind of talked about that a little bit. We've got a little negative charge here. He's a negative little guy. He's a negative little thief. He's a negative electron thief. Think of electrons as currency, okay? They are what can be spent inside a chemical reaction. So all negative ions are anions. They consist of only one element, only one capital letter in the symbol. Okay, remember that when you are writing chemical symbols, if there's more than one letter, then you have to write the next letter that represents it in lowercase. If you have two uppercase letters that are next to each other, I'm going to assume you're trying to say there are two different atoms there. Okay, so we need to be very particular about how we're writing this. Okay, I want you guys to, you are very smart young chemists. So use your skills, your study skills, and your practical life skills that I've given you here. Okay, so they have a suffix of "ide," anions in a suffix of "ide," and the "ide" takes over at the end where number one, the second vowel exists within the word, unless number two, unless it contains a Y. Okay, so here's what that looks like. Chlorine, which is a Cl, yields a chloride anion. See how the "ene" is replaced with the "ide"? Oxygen, O. Okay, see how this Y ends is replaced with oxide anion? Okay, and then we have phosphorus. Okay, remember this is the second vowel, is an O. Orus becomes phosphide, and that's a P-3 anion. Okay, and there are reasons again that we will look at about why it has a superscript of 3. If you recall from a previous lesson, we get full on positives and full on negatives in ionic compounds from ions, and these numbers are how many electrons have been completely donated or completely received. So this guy basically has 3 extra electrons. Does that make sense? Okay, I'm going to pause the video here and we are going to work this out. Alright guys, thank you so much. We're going to be doing some more drawing here for ionic comic strips. Okay, Remember, chemists try, and I appreciate all your hard work. I think you guys are all geniuses in your own right, and you're doing a fantastic job.